Hello, this is Mrs. Boots, and we are going to apply our knowledge of logarithms in money management and science. Remember when we did this with exponents, we did our compound interest and our growth and decay. Well, now we have one more equation we're going to introduce. First, let's review the other ones. Compound interest. So we have y, our final amount, a, the initial amount, r is our rate. Remember, it's a percent that we got to convert into a decimal. N was our frequency. That's when we said, how many times a year does this happen? Is it monthly, which is 12? And then T. T is time. That was easy. Then we did growth and decay. Y is still the final amount. A is still my initial amount. R is still my rate. It's still a percent, and I still have to convert it to a decimal. T is still time. D is like the N. It's a frequency. But with growth and decay, usually that D value is a 1. Now we have continuously compounded. I don't want you to just add money to my money once a month or once a year. I want it always happening because then I'm making money. Now, if it's a loan, that means I'm always paying money. I don't like that. But banks don't work that way. They do it for one, they do it for the other. Continuously compounded is the new equation. Notice the difference and notice the similarities. Y is still the final amount. P is like A. It's my principal. It's my initial amount. Instead of having this big long thing in parentheses, I just have E. Well, what's E? Oh yeah, it's that button on my calculator. So we have a button on the calculator. Well, that's a lot easier than typing all this in, right? R is still the rate. It's still a percent, and guess what? We still convert it to a decimal. T is still time. So the only difference was we took all this stuff inside the parentheses and turned it into an E. That is what we did with continuously compounded. We just put an E in there instead of all the stuff in parentheses. So we had some magic words before that told us what N was. If you look for the word continuously in the problem, if it says continuously, then you use the equation that has the E. That's simple. If it says compounded and tells you a time, like quarterly, monthly, annually, daily, we use compound interest. The rest of the time we use growth and decay. Let's look at a couple of examples. Example 1, we have $500 that's compounded quarterly at 6%. Okay, so our 500 is our A. It's our initial amount. 6%, change it to a decimal. That's my R value. Quarterly, we know N equals how many quarters in a year? 4. They want to know when it will double. So when means I'm looking for T. Yeah, we got to solve for the exponent. I know you're so surprised. But double. Last time we ran into that, it was a rate. Well, now we're talking about how much money we're going to have. So how much did we start with? 500. How much do we want? We want double that. What's double? 1,000. So the double tells us the Y value equals 1,000. So now we're ready. We know it's compounded with a specific time. We're using compound interest. We're going to plug it in. Y, my 1,000, equals 500 times 1 plus R, 0.06, divided by N, 4, raised to 4 times T. Okay. Now this is where we get crazy, right? Because students don't know what to do next. This whole parenthesis thing is attached to the exponent. So I need that part by itself on one side of the equation. What do I get rid of? I get rid of the 500. So I divide both sides by 500. When I do that, I get 2 equals the big ugly fraction to the 4t. Now, here's a trick. See this stuff right here in the parentheses? We can actually plug that into the calculator and get a single number for that. So we're going to end up with 2 equals something to the 4t power. So plug that in and figure out what the something is. So you're literally going to type 1 plus 0.06 divided by 4. You don't even have to use the parentheses. I get 1.015. Okay, so I got 1.015. Now, what am I solving for? T. Where is the t? In the exponent. What do I do when what I want is in the exponent? I turn it into a log. Okay, what's the base? The base is the 1.015. I go across the equal sign and I come back to get my exponent. All right, so let's turn it into a log. I would have log base 1.015 of 2 equals to 4t. Okay. Still, that's nice. Oh, wait. Is the base 10? No. Is it e? No. So what do I do when my base isn't 10 and isn't e? Yeah, we use change base. Okay, I can do this now. I got log 2 divided by log. Remember, the base goes to the bottom. Equals to 4t. What am I going to do with that 4 eventually? Yeah, I'm going to divide it. I'm going to divide it. But I'm going to get this whole big ugly thing and divide it by 4. Okay? Get the big ugly first and then divide it. So, on the calculator, I'm going to do log of 2, close my parenthesis, log 1.015. Close my parenthesis, hit enter. Now, divide it by 4. What do we get? 11.63. Okay, so time. When will it double? It will double in 11.63 years. That's how long it will take to double. I think I need a new investment strategy. I want my money faster than that. But hey, I didn't have to do anything. I just stuck it in the bank. And it still doubled. Let's look at number 2. 8,000 compounded continuously at 7.25%. Okay, continuously tells me I'm using this equation. All right? How long will it take until it's increased by 2,000? Okay, so this is a little different. So what did I start with? I started with 800, so that, or 8,000. That's my P. I know my R is 0.0725. Continuously tells me E. I'm using E. Increases by 2,000. So I'm going to have to add 2,000 to something. What am I adding it to? The original. So what's 8,000 plus 2,000? Yeah, it's 10,000. So that's my Y. Okay? So I've got 10,000 equals to my 8,000 times E raised to the what? 0.075t. Now, if you want to put an X because your T's aren't very beautiful and you don't want to mistake them for a number, that's fine. You can use X. Same thing as before. I need to get my exponent part by itself. So I have to get the E to a power by itself. That means dividing by the 8,000. 10 divided by that 8,000, I'm going to do it as a fraction. It's just going to give me 5 over 4, and that's going to equal to E 0.0725x. Now, I don't have to simplify the E like we had to simplify all the stuff in the parentheses, right? We had to plug all that in. It's a button. It's already there. But I do have to turn it into a log to get the exponent by itself. All right, so I need a log with a base of E. What is that called? What's a log with a base of e? Yeah, it's ln. Okay, so remember that log base e equals ln. So I'm going to do an ln, go across, and come back. Ln's of 5 over 4, and that's equal to my exponent, 0.0725x. All right? Okay. Well, this is just plugging it in the calculator, and then what are we going to do with the 0.70725? Yeah, we're just going to divide by it. 0.0725. Make sure you close your parentheses. Easy enough. Let's do that. So we have ln 5 divided by 4. Close the parentheses. See, isn't that beautiful? Okay. Now I can go ahead and hit divided by 0.0725. So I can do it all in one step. 3.07 what? 8? 078? What? This is time. It's years. Anything that's dealing with compound interest or continuously compounded is years. So basically, in a little over 3 years, my money will have increased by $2,000. I say that's pretty cool. Example 3. We have a population of animals. There's 450 of them, and they're decreasing at 16% per year. Okay, so am I using either of my compoundeds? No. We're in a growth and decay. So what is the 450? 450 is what we started with. So that's my A value. Decreases tell us it's a minus. We're going to subtract. And the 16% is R. R is 0.16. Per year tells us D equals 1. So we've got everything except time and Y. How long? I'm looking for time. Until it reaches 300. That's my Y. So let's plug it all in. So I have Y, 300, equals A, 450, parentheses, 1 minus, because it's decreasing, 0.16, to the what? T power. T divided by D, well, we're just going to put in X, because my T's kind of blended. Well, that doesn't look too bad, does it? Okay, let's see what we're going to do. Well, there's a couple things I notice. My exponent part needs to be by itself, and we can simplify this stuff in parentheses. One step at a time. We need to divide by the 450, right? I'm going to write it as a fraction. Okay, 300 divided by 450 would be 2/3. So I'm going to have 2/3 equals 1 minus 0.16 to the x power. Now we just said we could combine those, right? We can subtract 0.6 from 1. So I have 2/3 equals what? Yeah, 0.84 to the x. Well, that's not bad at all. No, it's not, right? I want to solve for x. Where's the x? It's in the exponent. If x is in the exponent, I turn it into a log. Where's my base? Yeah, my base is 0.84. So I'm going to have log of 0.84. Of what? Go to the opposite side of the equation. Yeah, it's the 2/3 because it has to be equal to the exponent at the end. Okay, so I put my 2/3, and that equals to x. Is x by itself, Nat? Yes, x is by itself. So now, we got to plug that into the calculator somehow. And I can't use my log button or my ln button, so I'm going to have to use change base. Okay? Base goes to the bottom. So I have log of 0.84 on the bottom and log of 2/3 on the top. Yes, I know 2/3 is 0.67, but that's if you round it, and I'm trying not to round it. Okay? Let's see what that is. Log 2 divided by 3, close those parentheses. Log 0.84. Okay, got it all in there. It's looking beautiful. What do we get? 2.33. Ooh, that's not good. In 2.33 years, the population will be down to 300. When it's down to 300, it goes on the endangered species list. So biologists and forest rangers will use this information to track specific species where we know we have a decline in the animal population to see how it's going to affect the environment. How long do we have to try and correct this problem before we now have an endangered species problem? Okay? And so what they do is they identify the animals when they're up here at 450 or hopefully a little higher. There's only 1,000 left. There's only 500 left. Let's go ahead and start looking at how do we get more of these animals? How can we breed them? Okay, or encourage them so that they populate and increase as opposed to decrease. And that way we don't end up with an endangered species problem. That easy. It's kind of cool. Let's look at example 4. In example 4, they gave us the equation. We don't have to write it. It's right there. Isn't that beautiful? The whole thing. Boom. And it's got a log in it. That's okay. We know how to solve those. All right. But what did they tell us? The height is 500. So where am I going to plug that in at? Yeah, I know. Brilliance. I'm going to plug it in right there for H. And they want us to find the pressure. Okay, that's easy enough. So let's plug it in. So I have 500 equals negative 20,500 ln of P over 4730. And I have students who get that far and then they throw up their hands because they have no idea what to do next. Remember, we always make sure the exponential part was by itself? Yes, the same thing applies to the log. I gotta make sure the log is by itself. Okay, in order to do that, we're going to divide by this wonderful number out front. And we can get a decimal or a fraction. Either way, I did this one in a decimal because it was so big. And it is a negative 0.024. That equals to ln of P over 4730. Okay, so now my natural log, my log is by itself. Where is the x? What am I looking for? P, and it is where? Inside the log. So if it's inside the log, I have to do what? Turn it into an exponent. Okay, so we need to rearrange it. My base is what? E. Okay, so I'm going to have E to a power equals to the stuff inside. Okay, so E to the power of negative 0.024 equals the stuff inside. What are we going to do with that 4,730? Yeah, we're going to end up multiplying. You know this is a number, right? The E to the power, we just plug it in the calculator. We got a button for E. Yeah, we're going to plug it in the calculator. So we're going to multiply by that 4,730 on both sides. So it cancels over here, so I get P by myself. Okay, let's plug that into the calculator. So I got 4730 E, that's second ln. The exponent is negative 0.024. All right, so that's what we got. We just plugged it into the calculator. We hit enter. Wow, 4617.83. So P equals 4617.83. That's time? No, that's pressure. Different problem, okay? I can have pressure that high. I mean, look. The pressure in the atmosphere goes that high. That's okay. Good answer. Example 5. We have a population of bacteria. Somebody's growing it. And they have a formula that I've written on the board. And the initial number of bacteria, that's the N0. So that little 0 is to tell you it's an initial amount. The N is the number that it has. That's the final amount. They tell you T is in hours and K is a constant. Well, hold on. Wait just a second. This looks really strangely familiar. Compare this. Yeah. All they did was change the letters. It's the exact same equation as continuously compounded. Only they're using it for bacteria, so they changed the letters up. No big deal. So let's look at what we started with. They told us we start with 300 bacteria. So my 300, that's what I'm going to plug in for N naught. They outright told us K is 0.068. Beautiful. When will it reach 10,000? Well, that's got to be my N. So let's just plug it in. I have 10,000 equals to 300. E, I have my K, 0.068, and I'm going to put a big old X there for T. Okay, what do we do now? Yeah, we got to get the exponent part by itself, which means we get rid of the 300. Divide both sides by 300. So I'm going to keep it as a fraction. I know you don't like it, but I do. So I've got 10 over 3 when I reduce my fraction, and that's equal to e to 0.068x. Okay, my exponent part's by itself. I need to solve for x. How do I get the x out of the exponent? I turn it into a log. What's the base? The base is the e. Go across, come back to set it equal to my exponent. All right? So I have a log base e. What's log base e called? ln. So I have ln of what? 10 over 3. Come back around. That's equal to 0.068. X. Can't forget the x. What am I going to do with that 0.068? Yeah, we're just going to divide it. 0.068. So it's going to cancel over here, leaving my x by itself. And on this side, yeah, we just got to plug that in the calculator. What's the only trick? Remember your parentheses, right? So I got ln 10 divided by 3, parentheses, divided by 0.068. See? Plug it all in at once. There we go. Hit enter. What do we get? 17.71. Okay. 17.71. 17.71 what? Days? Years? No, they said it was hours. Okay, let's think about that. In 17 hours, the bacteria is going to reach 10,000. Okay, not good, right? Well, that's what happens. Remember, that's why you're in the morning, you're like, oh, my throat's sore. Feels a little scratchy. And then, you get through your first couple glasses and you start coughing. That's because the bacteria is multiplying so quickly. And this wasn't even that multiplication. It was just 0.68. Okay? So 17, almost 18 hours later, we have a huge number of bacteria, and that's why we have to take medicine sometimes. This concludes all of our examples for applying logarithms.